Okay, so homework for today was we already have our app going through and handling all of our individual instructions, right? So we weren't adding any new individual instructions to our code, but now we wanted the ability to process multiple instructions. Basically, write a program in here, hit execute, and have it go through each of these instructions, executing them, showing us the final state of registers or memory when all was said and done, right? Okay, well, now we already have a machine effectively for executing a single instruction with its parameters. That's inside of instruction. Instruction can execute something. So really what we need to do here is we need to process this is an edit text, right? So this is instruction ET for multiple lines. Okay, so let's see, this is main ET? Main activity. Okay, so here is our execute button pressed. So right now we're just getting our instruction with the instruction ET get text, but now this guy's a little bit more interesting than he was before, right? So we're going to go ahead and we're going to throw that into a string. So we'll say string the instructions. I'm actually going to change the name of that guy here in a second. Which is called string S for right now. Okay, and I will just comment out this other stuff for a few minutes as we start going through this. All right, so we want to look at the nature of our instructions. So if I just do a system.out.println S right now, and I'll actually, just so we can see it pretty easily, I'll put some asterisks before it. Just proving we're reading in from that guy. So right now we don't execute any instructions. We just spit out the multi-line thing that we have there. So let's just make sure that that's working. And then we're going to analyze that string a little bit because we need to figure out how do I get that string to break up into the individual instructions. Okay. Because really that's the whole assignment, right? How do I break this guy up into individual pieces? All right, so in order to start, we have to think about this goes back to just plain old string manipulation. Okay, but we need to understand what our string currently looks like in order to kind of do that. All right, so I'll come in here, I'll just hit the execute button here real quick. And then I should be able to go into Logcat. And I'm going to click on verbose. Then I'll just put in some of my asterisks there. Okay, so let me look at something here. Is there only one thing in there? Okay, so we get one. So when I read in get text.toString, I'm only getting that very first one.
Get all of them.
I don't see all of them. Is it because
you searched on system.out instead of the asterisk?
Oh, because the asterisk is part of this thing. Yeah. Good point. I figured that would show me any line that started with that. Yeah, because of the way it outputs it outputs all the individual system outs, and only one of them had the thing in front of it. All right, so here's all of our individual pieces. Good. All right, so now this just looks like plain Jane stuff, but what I'm going to do now is I'm going to go through this, and I'm going to do system.out on each individual character. Okay? So I'll just leave that there for now. So I'm going to go ahead, I'm going to say for int I is equal to 0, I is less than s dot length, I plus plus. All right, and we'll do a system.out.println, and we'll say s dot charat I. We'll go ahead and get this guy out of there. We'll hit play here. So now I should get a whole bunch of stuff printed out once I hit execute. Okay. And the end of that first line is three. Let me look what my first line looked like. Ended with the 7. All right, so we have a 7 here. The next one was the add I. And I say I think println is going to mess up the way I want to see this. All right, so what I'm going to do is I'm going to change this into an int. Now, by changing a character into an int, what am I actually looking at? Yeah, the Unicode version of it, since the characters we're using fit into the first 256, it would be the ASCII code. So I'll run this again. And what we're trying to figure out here is what does the end of each of these lines have on it? What is this last invisible character here before it kicks down to the next line? Oh. All right, so we have a whole bunch of stuff. Let me go to the easiest way to find it would be, so So 1, 2, 3, 4, 5, 6, 7 is the 51, 8, 9. So it's 55, the guy I'm looking for. Do we have another 55 soon? Maybe we'll just do a lookup for. So line feed is \n. Does it give me what the number is for this guy? We could just search for it by character. I was just trying to take you down the path of seeing it for the individual. Let's just do Unicode value. Easiest way is going to do this. System.out.println. I want the int version of the char \n. See what that guy gives me. I'll just get rid of that for a second. So we'll just have a single print statement right now. All right, so looks like it's a 10. Let's make sure that's the right one. Yeah, 10. Okay, so I printed out the Unicode value of a \n. Now, I don't remember seeing 10s in here necessarily, did I? Yep, there was a 10 there. There was a 10 there. All right, so they exist. They're in there as characters. All right, so, we're kind of looking at the Unicode characters. We're starting to see that we have 10s. You have to kind of walk through the order of saying, okay, well, here's the Unicode for M, O, V, Z, so on and so forth. And you get right here, and there's actually one extra character here before you get to the A. Now, if you just print out this character, now, in actuality, we already saw evidence of this a few minutes ago. We were printing out individual characters. What happens if we print out the character \n? What does the character \n do when we print it out?
New line.
Yeah, it kicks it out a line. That's what it tells the terminal to do, right? So we don't actually see anything there. We don't see a space. It kicks down a line. It's an invisible thing. But that guy is the Unicode character 10. So this tells us that at the end of each of these lines, we have somebody press enter. And that ultimately produced the symbol \n. Carriage return, line feed. It's actually technically a line feed. Carriage return \r is the old kind of DOS way of handling that. \n is typically used to represent both carriage return and line feed today in modern terminals. All right. So with that in mind, go ahead. What?
Except Windows still does the /b/r. So on Unix.
You mean /n/r? Because on Windows, WordPad works one way and Notepad works the other.
Yeah, on Windows, new lines are 2 characters, whereas on Unix, it's just the one \.
So it must be just Notepad then. In Notepad, it's \r/n, because in WordPad, it matches Unix, which is just \n. Those two work differently.
Right.
And where you can sometimes see that if you've ever pasted text in there and you get the strange boxes in Notepad, or in WordPad rather, that's the extra character that they didn't know how to deal with. Okay, so what we're going to do is we're going to start off by going through our characters. And so now I've already have we used split in here for our instructions? So we're already used to using split. Okay, so we'll just do that. So what I'm going to do here is I'm going to go ahead and I'm going to say we're going to create a string array called instructions. And we're going to set this guy equal to s.split on, well, that's fine. Split it on the empty string, or on the string containing a \n. All right, then we're going to go through all the strings in instructions. And we'll tell each of these guys just to print themselves out in their entirety. So this is instructions at bucket I. This is instructions.length. That's an array. Okay. All right, so now when we run this, we'll read in our string. We're going to split it on a carriage return, giving us a string array. If I initially want to say system.out.println instructions.length to tell me the number of elements in the array, it should equal the number of instructions that I have. Potentially the number of instructions plus 1 if I had an extra enter at the end. We'll see if that was the case or not. But it should be more than 1. We should have several things in there. All right, then I'm going to loop through and I'm going to print them all out. It won't necessarily look different than it looked before, because before, when we printed them out, we were also printing out the carriage returns. So I was kicking it down to another system.out.println, where in this case, the carriage returns are gone because we split on the carriage returns. And now we're going to get the prints. It's possible we could get some blank lines if we had like pressed enter twice or something like that. But we should have them broken into individual pieces. So let's look at that. All right, so we have 5 instructions, and here's each of those instructions. They look all nice and tidy just because we wrote it to be nice and tidy, but the reality is that we, if I come into my instructions and I put some extra spaces and stuff in there, there would potentially be extra spaces. on either side. So it would be in our best interest probably to trim these guys.
Aren't we trimming when we make them?
Probably, we probably are. I think when we pass it into, you're saying, are we trimming here, right?
Right. Or, well, actually, I believe it's in it.
We trim right here.
Yeah.
Yeah, so we do already trim. Yeah, I don't know what the best advice I can give you there is. Better to trim twice than not trim at all. Something like that. So in that particular case, I would have been inclined to probably trim in here, just because in the moment I'm here thinking that it's like, oh, well, I might have some extra spaces. So I'm going to go ahead and trim here just in case, when the reality is, as you pointed out, we are already trimming in here. So it actually would be redundant and a waste of performance. But you'd probably rather do that than forget to trim and have a weird error. So probably the real correct way to do is just go and check to make sure you're trimming somewhere in the flow. Okay, so I'll go ahead and execute my instruction. So the instruction I'm executing is going to be the instruction at bucket. I can't name my instruction I here. Let's do that. All right, so with my instruction at bucket I, build an instruction out of it, execute that instruction, loop back around, do the next instruction. Finally, we'll print out, we'll make some toast. And it should tell us we're done with our instructions. All right, so this should be the solution to the homework. That should be what we had to do, right? Go through the thing, break it up, call instruction on each thing. We didn't need to change anything anywhere else. So now we need to look at this. Let me run it real quick, and then we'll decide what should the code do. Because after we're done running it, we should be able to go and look at registers and look at memory and see the final state of things. Make sense? Okay, so move Z. So we're moving a 7 into X3. Then we're adding a whatever's in X3 plus 5, storing the result in X1. So we should have a 7 in X3. We should have a 12 in X1. Then we're moving into X4, 13. Then we're adding the 7 plus the 13, giving us a 20 in X0. And then we're going to store X0 into X1, which was a 12 offset 5. So a bucket 17 in memory should have a 20. I think that's all right. Okay, so we'll execute that. Row. So I'm thinking we must have had an empty instruction there. Let's look at what our error was. All right, we tried to parse int. This is from this guy. We tried to parse int on STUR, so it was right here. Do we have a bad format, STUR? That's right, comma. That looks good, that looks good. So let's see what this instruction looks like up here before we execute this. I'm just putting those asterisks on either side of it so I can see if there's any extra spacing or anything like that. So every single time I create an instruction, I'm just going to go ahead and print out the instruction I'm creating. And we're going to see if we have a bad egg in there. This could just be our very last guy or something, but we will see. Go ahead and run this. It's going to crash, but we should still have our system.outs. Okay, so it's probably this space right here, right? Before the 5. Looks like that's where it's happening. So must not be trimming that value. I think it's trying to parse int of a space 5. So we go into instruction. I'm trimming the entire thing at first. That's fine, so that gets anything off the ends. I get the first space, I get the magic trick, I get the rest of the stuff, also trimming it, but then I split on the comma there, but that's going to potentially leave me, so I'm stuck with something that looks like that, I think, in this particular case. I think we could prove it to ourselves real quick if I just go into the prove that that's the problem. If I just go in here and I take that space out before the 5 and then execute, yeah, so that was the problem. So that guy did fix it. We'll go fix the code here in a second, but let's just look at our registers. So here's our registers. We have a 20 in X0, a 12 in X1, a 7 in X3. That looks correct to me. And then we should have the 20 in memory. Bucket 17 here. There's our 20. All right, so this guy does what he's supposed to do. We just have a little bit of a formatting error that we can fix up right in probably the best way to fix that. Since we want those parameters to benefit us throughout, we can probably just zip through and split all our trim all the parameters in one place rather than having to go through and place special, do special situations in here. So up here, after I get my parameters, I'll say trim the parameters just in case. So we'll say for I is equal to 0, I is less than this dot parameters dot length I plus plus. And we'll say this dot parameters at bucket I is equal to this dot parameters at bucket I dot trim. So just clean it up a little bit there. Now it should be okay with us having that extra space in there. So extra space is in there right now. Now it's happy with it. There's our registers and our memory. I should have picked a bucket that didn't require me to scroll. Here's my 20. All right, questions about that? All right, so now we're able to solve have effectively an ARM program, right? We can put it in there and we can see the state of the registers and all that stuff. Okay, so now for kind of polishing this off, we can obviously just keep going and do all sorts of stuff, add more instructions and things like that. What might be nice for us to do is, I mean, as it stands right now, we have to type in these instructions by hand and kind of remember the syntax and stuff like that, right? It might be nice to kind of have an instruction builder, something along those lines. Okay. Now this is really kind of maybe stretching the I don't know what the app has to do, but if you're thinking about this app maybe being a teaching tool, and you don't necessarily know what the exact set of instructions are for something, maybe I have like a little button underneath here, like a little add button or something like that, where I want to add an instruction to my list, something like that. Now I can certainly come in here and type stuff. No harm, no foul if I know what I want to type, but I can have a little add instruction, and maybe that takes me to another screen that lets me select the instruction that I want to build. And then what it does is it maybe, if we wanted to put it on steroids, we could have it let us actually go in and fill in the parameters for what we want it to say. And then, otherwise, maybe initially, we'll just write it maybe in 2 steps. Maybe initially we let it choose our instruction. It'll go ahead and add it in here with generic syntax that we can go in and change it a little bit, just to prove that we were able to do that. And then maybe we can have it, once we select something, it allows us to replace those things, give us little edit text for putting our own parameters in there. So it'll add the text to the bottom of our list for us. Kind of makes some sense? Okay. So we'll put a little add button in here. And this is more just a little extra bell and whistle thingy majiggy. So nothing, let's say nothing earth shattering. So I'll throw a button in my linear layout here. I'm going to change this guy's button to a little plus sign. Then I'll have his width wrap content. And then I'll set the gravity to right. Oh, that's to the button, sorry. I want the gravity of my linear layout to be right. There we go. So we have a nice little button there. So when we hit this, it's going to take us to a screen where we can select the instruction we want to add. Okay, and this guy is going to have all the different instructions that we have available to us. Okay, so let's build that screen. I'll right click here. We'll say new activity, empty activity. Okay, and we'll call this guy instruction picker activity. Hit finish. Okay, and then in activity main, let's go ahead, or main activity Java, let's go ahead and write our function for that plus button. So we'll say public void add instruction button pressed view V. All right, and what this guy is going to do is he's going to create an intent to take us to that other screen. We might do some other stuff in here with like maybe something with a singleton to kind of store where we're going to put our value or something, but we'll get to that in a few minutes. So we'll create an intent. I is equal to a new intent. Am I doing this right? Context this, and then it is, what do I call it? What's the name of my class? This looks like things are still cooking kind of funny. What did I just name that class? instruction picker activity. There it goes. All right. So then I'll go ahead and say this dot start activity I, and that should start that guy. So we need to set the add buttons on click to this dude. So that is in this guy. There's our add button. Here's his on click. Here's our add instruction button pressed. And let's make sure he takes us to that screen. Okay, and he does. I'm also going to give myself a clear button here to empty out this guy. Because we kind of like to have the stuff in there initially for testing, but we might want to test our other thing in a few minutes. So we'll give ourselves a second button that just clears out that that input. Should only take a second-ish. Activity main. All right. Okay, so that guy will say clear. I just put it in a horizontal linear layout. I'll set the gravity of this guy to right, which means I can actually take the gravity off of our vertical one. It wasn't hurting anything, but technically was adding one level of complexity to the layout system. So, because now we have a vertical linear layout that doesn't have gravity associated with it, but inside of that I have a single horizontal linear layout that has two buttons in it, and that guy has the gravity set at right. Okay, so we'll go ahead and hook up this clear button, and what is the clear button going to do? It's going to set instruction ET to be the empty string. Okay. You know what actually could be helpful? I'm going to do another button too. I want to do a remove last. So I'm going to do clear all. I want to do remove last, because that could be helpful if we go in to add an instruction. We add the instruction. We're not happy with the instruction we added. It gives us a halvesy kind of granular thing to just kind of undo what we just did and try again. Something like that. So I'll throw one more button in here while we're at it. And we'll do that maybe in the middle there. Okay, this guy's text will be remove last instruction. I'll just change to remove last. Okay, and I have his width set to wrap content. Oh, that actually doesn't look bad. All right, so I need to write my clear and my remove last functions real quick. So clear is going to empty instruction ET. Remove last will just remove the last thing from instruction ET. So let's go with that. So we'll say public void clear button pressed. And this one's an easy one, right? So this is view V. And this guy will say this dot instruction ET dot set text to the empty string. All right. So now the other one, though, this one's a little more interesting. So this is going to be public void remove last button pressed. And what I want to do is I want to remove the last instruction that is in my edit text. How would I do that? It's kind of a fun, kind of like a 250-ish type of, write a method that, has a string, to write a method that has a string delimited by \ns and remove the last, return a new string that is the original string with only the last element removed. How would I write this?
You define it next to the last line.
Okay.
Starting the last line.
All right. So that's her contribution to this question. So we find her index of the last line. How do we do that? She already gave away part of the answer, but we'll just let it ride with that. Go ahead.
Well, if we split it into an array.
Okay. And you want to split it on \ns?
Right.
Okay. So let's start with that. So you want to create a nice little string array called
String array.
I'm going to call this instructions. And this guy is going to be equal to this dot instruction et dot get text dot to string dot split on \n. Like that. So now we have our nice string array with all that crap in it. Okay. Now what?
Well, our last element is going to be instructions.length -1.
Okay. I agree. So what do we want to do with that guy?
Set it to the empty string.
Okay, we could do that. So you just want to say something like instructions at bucket instructions dot length -1 is equal to the empty string. Gonna spray paint over it. It's not there anymore. It was like a perfect spray paint sound. You hear it? And when you're just trying to be like real artsy with it, because otherwise it just blows everywhere. And then don't do that when you're wearing glasses. I ruined a pair of glasses with it. Like you don't think that there's spray paint particles in the air, but there is. And can't get that off your glasses. So what's next? So I've split it into an array. I've spray painted over the last element of the array. So in theory, we've spray painted over the guy we don't want. But now what do I need to do? Removing the last element implies what?
Wouldn't you want to make a new array that's shorter?
Okay.
Like, instead of just covering one last element? Or find a way to make the array itself shorter.
Okay. Do we really need to make it shorter? I mean, you're not going down like a horrible logic path.
Yeah.
We're just doing some like unnecessary steps.
In theory, we just craft this array into a new string.
Okay.
And the long way to do that would be using a for loop. And we have our string new string, which we concatenate itself with element I of instruction.
Yeah.
Plus \n.
Okay, so then toss an extra back. Okay, that's the long way. So what's the short way?
I'm not sure.
There just has to be one.
Probably some built-in function.
There has to be a short way. Okay, so now, do you still want to spray paint this guy or no?
I suppose that wouldn't technically be necessary.
Because we could just go through one less
Right.
element of our array. So we'll go through our array here. For int I is equal to 0, I is less than instructions dot length -1, one less time. So we'll just ignore that last guy, like he's not unimportant, right? And then we'll say I plus plus. All right, and then you said you want to build up a new string. So we'll say string. I'll just call it answer. Start off as the empty string. And then what we're going to do is each time through, we're going to, now we can do this a couple different ways. Ultimately, you want to say, ooh, where'd that guy come from? See, I really don't like this trackpad. It's a thing. So we'll say answer is equal to whatever answer currently is, concatenated with instructions at bucket I, concatenated with a \n. Something like that. Now, the issue we're going to have with that, though, small issue, but possibly an annoying issue, is we'll be stuck with one extra carriage return at the very end. Go ahead.
Oh. Could you get rid of that by initializing answer to be the first thing and then have \n answer equals \n plus instruction?
Yeah, I don't dislike that. One potential thing to be careful of with that is that we might have to do some error checking here to make sure that there actually is something there, because we can technically hit remove last when there's nothing in there, and then it just croaks on us, right? You know, so we probably want to make sure there's at least something in there. But if we do that logic, then it probably is reasonable, as you said, to do this and then start this guy off at bucket 1 and then concatenate on the \n. Sorry. Before our instruction.
Even if it's empty, though, won't our first thing just be an empty string because we're taking everything before?
It's possible. Your question is will split on \n of the empty string give you an array with exactly one element in it? That's the empty string. The answer is maybe. That might be a true statement. But it's still something we should concern ourselves with and ensure that that's the case. All right, so we'll store our current answer. Then we'll go through and fill the rest of answers, everything up to but not including the very last thing, with carriage returns in between each one. And then ultimately, we're going to set this .instructionET.set text to answer. We'll overwrite what's currently there with our one less guy. Make sense? All right. So we'll go out here to Activity Main, make sure we hook up those two buttons. So here's our on click for remove last. There's remove last. Did we already do it for clear? We didn't. So there's clear. All right. So let's test remove last and let's test clear. We'll find out pretty quick whether you're right about that. So if I do remove last, it's removing the last thing. So it actually won't get rid of the very, very, very last thing, though, in that particular case, because we're still storing bucket 0. So really, if its length is 1, I'm not sure this is a major issue. That just could be like how the app works, because clear will let us get rid of that, right? So let's just call that good enough. we can sit there and screw with it and make it work in a little bit different way, but let's just say it's fine. All right, so we certainly now have the ability to mess with our instructions there. So, you know, the ideal situation is maybe we come into our app, we want to test the current state of things like we were doing, you know, so we can hit execute. It runs that memory and registers are set to whatever. And then we want to go ahead and try some new code, so we just hit clear. Something like that. We could also maybe make the argument that clear should also clear out our registers and stuff, but we could also make the argument that it doesn't. So we'll just leave it alone. Okay. So now we want to go ahead and make this plus button do something. So on this screen, we want to have them, give them the ability to choose which instruction we have, and then go ahead and add that instruction onto this previous screen in a generic format that they can then go and type over initially to let them kind of pick an instruction and then fill in the blanks with how it should look. Okay, so on this second screen, this guy. I need to give myself a vertical linear layout. All right, and then I'll go ahead and give it a text view here at the top. We'll have this guy say, pick an instruction. So pick a instruction.
Should be in.
And pick an instruction. That's a weird sounding one, isn't it?
It does sound
Pick
weird, but
an instruction. Yeah, it is and. Yeah. I think it sounds weird because of the I after it. An instruction. Yeah. Like and followed by in. Oh, well, I didn't get it right anyways. Pick an instruction. There we go. And we'll bump the font up a little bit there. And we will center this here. Okay, then I'm going to go ahead and I'm going to give myself a scroll view, maybe to put some buttons in or something like that. Realistically, I probably don't need a scroll view, but as we get more and more instructions, it might be handy to have a scroll view. Right now, I think all of our instructions would fit on the screen, but we'll still use a scroll view. Drop that guy in there. Scroll view comes with a vertical linear layout. And we'll go ahead and put some buttons in here. So what are my instructions that I currently have? Instruction. We support add, subtract, add I, subtract I. So let's do the two adds and the two subtracts next to each other. All right, so this guy will be add I, sub I. I don't need to go someplace else. Load and store and move Z. Load, store, move Z. Move Z like that. Okay, so the idea is when we click one of these buttons, these guys are going to, well, presumably when I click this button, it's going to take me back to the previous screen, having inserted a new line at the bottom of the thing that is the generic form of our add instruction, something along those lines. Okay, and what's the generic form of an add instruction? Let me go into here real quick. Okay, so what I'm going to do is I'm going to create a an array in here that's going to be my instruction syntax map, something like that. So I'll make a public static string array. Instruction syntax map. Okay, and this guy is going to be equal to. So we have add is dest register followed by source. Isn't it the other way around? Isn't it source 2 then source 1? Because that doesn't matter for add, but for subtraction to work, it's the, I don't know, it could be kind of confusing.
I mean, we have it written down in instruction.
Well, right, I'm just saying how we've written it is maybe unimportant. If we just say source register 1, source register 2, and let the programmer decide that, oh, I need the sources I need to put in for at least the subtraction needs to be the other way around. I think that's okay. So we can call this guy source reg 1, source reg 2, something like that. Is that a reasonable syntax? Add I will be des reg, source reg 1, literal, or maybe the cleaner way of saying it is just number. If we're really trying to teach people how this works, right? I mean, probably the most correct thing to say would be immediate. We want them to know what immediate means. Let's say yes. Is immediate spelled with 2 M's or 5?
7.
Just 1 M, right? 5? All right. So then we have sub dest reg, source reg 1, source reg 2, sub I, dest reg, source reg 1, immediate, and this is sub I. And then we have load and store, LDUR. Now, when we're loading into a destination register, right? So this would be a dest reg. And we are storing, or we're loading from a place in memory with base address reg, comma, offset, something like that. Base address might end up becoming too long. Well, we'll see. If it's too long, we'll shorten it. So that's load. Destination register, then where we're, and then store, STUR, is source register, comma, base address reg, offset, because we're storing it somewhere into memory. And then move Z is dest reg, comma, immediate. All right, so that's a whole bunch of our mapping things. All right, so whenever they click on one of those buttons, we want it to map to the one of these strings and have that string added to our text on the previous screen. Make sense? So let's start off with having it us determining which button was clicked. So what I'm going to do here is I'm going to come into our instruction picker, and we could do a couple different things here. We could take all of these buttons, we can load them into an array, and then depending on which button was clicked, we can get the index of that button in the array, then map it up to the starter instruction up top. Similarly, we could do something with a bunch of if statements. So if it's add, if the button that was clicked gave us had the name of add, do this, otherwise do this. So I'm going to do this as I'm going to name these buttons to match up to this. We're going to call this guy add button, add I button, sub button, sub I button, LDUR button, STUR button, and move Z button. All right, so now all my buttons have known names. So I'm going to go ahead and give myself access to these buttons in code, but I'm actually just going to put them into a list. So I'm going to have a list of buttons. So I'll go into my register detail, not the register detail. Where's my code? Activity instruction picker, this guy. So at the top here, I will give myself a private list of button objects. Oh, I need to give myself and we'll call this guy the buttons. This will be equal to a new list of buttons. All right, then inside of onCreate, I'll go ahead and fill that list up with all of my, let me make this a linked list because list is abstract. Okay. So now I'm going to go through and I'm going to fill up my buttons with the various buttons from my interface. So I'll say this dot the buttons dot add, and I'm going to add the button version of this dot find view by ID r dot ID dot add button. I'll do that for all the other buttons as well, making sure that the order I'm adding them here matches up to the order I have in my singleton, because I'm going to map them to each other. So this will be add I, sub I, load, store, move Z. Is that all of them?
I think if you just press tab, then it would be okay.
Yep. Okay, so those guys are all filled in now. So now I'll create my function. So this will be a public void on instruction button pressed. This guy will take a view v as a parameter. So now I want to find the position of v inside of my collection of buttons. So I'll write a little function here. So maybe I'll say int pause is equal to -1. You know, I'm actually going to write this in just another function real quick, just to keep this relatively clean. So I'll make this private int index of button. Okay, and this guy will take in a button B as a parameter. And we'll say int pause is equal, well, we'll call it index. Int index is equal to -1 for int I is equal to 0. I is less than this dot the buttons dot, is it size dot length? Oh, lowercase s size.
Yeah.
I plus plus. All right, then we'll ask the question if B is equivalent to this dot the buttons, is it dot get I. If that's true, then we will return I guess I didn't even need this index thing. Otherwise, go on. If we survive this entire for loop, we'll return a -1. So it works just like index of does for strings. So I'm going to go through all my buttons, asking each one, are you equal to B? And this is how I want to ask it. I want to ask it with the double equal sign here, even though that's the primitive operator. I'm saying, is this guy's memory address the identical memory address to the button that lives here? Are they the same button? If so, return its position. If I never find the button, I'll just return a -1. Now we know we will find the button in here. So I'm going to go ahead and I'll say int pause of button is equal to this dot index of button, passing it the button version of V, because I'm going to have all my buttons set to call this function. And they're going to pass themselves in as the parameter, which button called the function that time. I'll go ahead and look up that button inside of index of button. And then I'll go ahead and say system.out.println armap dot instruction syntax map at position pause of button. All right, then I'll let all those buttons know about that guy. So this is on instruction button pressed. On instruction button pressed. And then we'll test it real quick. And for your last homework assignment, get the selection of this button to update the input ET on the previous screen. So as it is right now, when we click one of these buttons, it should print out to Logcat the generic syntax. So what I'm saying is, rather than print that to Logcat, add that to your input on the other screen. Click plus here. There's add I, sub I, LDUR, STUR, move Z. Should be able to go into Logcat here. Go all the way to the bottom. And there's our generic syntax for those instructions. Make sense? So add this generic syntax as the last line in your in the input thing on the first screen. So if I click add, the last line on this thing should have add destreg, comma, source reg 1, comma, source reg 2. That I can then go in and manually edit because it's giving me kind of my paint by number. Make sense? All right, so I'll push this code up to whatever it's called, GitHub. And next time we'll go over this real quick. Shouldn't take very long. And then we will review. I'll go through the slides and tell you what to expect on the final exam. I will see everybody on Thursday. Remember, if you're interested and you're around tonight at 7 p.m. in the old Fishbowl, 109 across the hall, we are watching Imitation Game on this giant TV. It is the story of Alan Turing and how he led a team of people who cracked the Enigma code. Really, really cool computer science-y, hacker, cryptography, dealy flippy thingy.
No extra credit?
No extra credit. You should come because you want to.
I need to talk with you about maybe two things. One, making up for Bible assignments if it's possible.
Okay.
And two, potentially taking a grad course next semester.
Taking a who?
Grad course next semester.
Okay. Have you taken one yet?
Yeah, I took 518.
Okay, you took 518. Do you have a room in your schedule for one next semester?
I do, yeah.
Now you're going to be a junior?